All right, so we're going to look at the difference between simple or an independent-dependent probability, just to really emphasize how you tell which is which, and again, to emphasize those differences and similarities. So we're talking about a bag of marbles that has 9 red marbles, 8 blue, 3 green, 7 purple, 12 orange, and 11 yellow marbles. And we're just looking at problems where a marble is chosen at random from inside the bag. So first thing first, remember that our definition for probability, we're talking about the favorable over the total number of outcomes. So the first thing I did was figure out my total number of marbles. I took all of my 8, 9, 3, 7, 12, and 11, and when I added those together, I got 50 total marbles we're looking at. And then we have A, B, C, and D are the problems we're going to look at. So letter A just wants us to figure out what is the probability that a purple marble is chosen. Okay, what's the probability that a purple marble is chosen? Well, our problem says that there are 7 purple marbles. 7 purple, so that would be our favorable outcomes. Out of our total outcomes, well, we decided there were 50 total. Now this is simple probability because it was really simple to figure out, right? There was one thing. Anytime that there is one thing going on, that's going to be simple probability. There's nothing else. Again, it's just very simple to look at. You don't have to do anything extra like the overlap or multiplying or anything like that. It's just, you look at it, it's favorable over total, simple as probability gets. So for this particular problem, the probability of choosing a purple marble from this bag is 7 out of 50. That's our simple probability. Looking at letter B, what is the probability that a purple or a green marble is chosen? Let me get a different color here. So we want purple or green. Well, we already know that there are 7 purple. How many green are there? 7 purple and 3 green. Now, the big clue in this, in letter B, is that it says or. Or, anytime you have the word or in the problem, it's or probability. That one's my favorite because it's very straightforward. If the word or is in there, it's or probability. Very difficult to confuse, all right? It's or probability is what we're looking at here. And for that, remember, we take the individual probabilities and then we subtract any overlap. So the probability of picking a purple marble is 7 out of 50. Plus the probability of picking a green marble would be our 3 green marbles out of 50. Well, purple and green are 2 distinct colors, so they don't actually have any overlap, so we don't actually need to subtract anything. So for our final answer, all we have to do is take 7 plus 3. Well, 7 plus 3 is 10, so 10 out of 50 is our probability, but remember, we need to simplify if we can. We can divide 10 and 50 by 10. So our probability that we pick a purple or a green marble is 1/5. Then, so that's or probability. Simple, it's really simple, it's one thing. Or probability, it literally has the word or in there, and you account for that overlap. This is our, in this case we didn't have any overlap, but you account for that overlap. And then this week we talked about independent and dependent probability. And independent and dependent probability really just comes down to if the probability is with replacement or without replacement. That's what you're really asking yourself when you're asking yourself if it's independent or dependent. So letter C, get another color again. Letter C, calculate the probability that you choose a blue marble, put it back, then choose a yellow marble. And we want to know if this is independent or dependent. And what we need to look at is this phrase that they gave us, put it back. Well, if we put it back, that means we replace it. So this is going to be independent because this problem is with replacement. So remember, if we replace it, basically we're resetting it at the beginning. Okay, if we replace it, we're resetting it. We have the exact same conditions or the exact same chance of getting a blue marble as we do of getting a yellow marble because we reset everything when we're looking at the yellow marble probability. So that's with replacement. So they're independent of each other because nothing changed from the blue marble to the yellow marble. So anytime you put it back, anytime you replace something, that's going to be independent. Now, remember, for independent and dependent probability, we're going to multiply. So let's look at our individual probabilities. Well, the probability of a blue marble would be 8 blue marbles out of 50 total. times the probability of a yellow marble would be 11 yellow marbles out of 50 total. So we have 8 over 50 times 11 over 50. Be a good idea to pause and see if you can solve this for yourself just to make sure you're on the right track. So 8 times 11 is going to be 88, and 50 times 50 is 2,500. Now the last thing we need to do is we need to determine if we can simplify this at all. And for this problem we can, and so 2 goes into both of them, but I'm going to try 4 just because I like to, if 4 works it'll be a little bit faster. So 2,500 divided by 4 is 625, and 88 divided by 4 is 22. Now the only numbers that go into 22 are 2 and 11. 2 and 11 don't go into 625. So our probability, I'm going to write it over here, is 22 out of 625. And I would like you to write these as fractions. Write them as fractions. Please do not write as decimals. Okay, and that's just because I want you to practice the simplifying. And honestly, the fraction means a little bit more when we're talking about the favorable over the total as opposed to a decimal. In that context, it just doesn't mean as much. One problem left. Letter D, we want to calculate the probability that we will choose a green marble without replacing it. And that's that key word, without replacing it. So we're not putting it back, we're keeping it. Well, if we're keeping it, we have a different number of marbles. For the green marble, we start with, 3 green marbles and 50 total marbles. But if we don't replace that marble, then the probability, when we look at the probability of getting another green marble, we only have 49 total marbles we're looking at because we took one out. So in this way, our second probability, the probability of picking another green marble, is dependent on that first probability, and we know that because this is without replacement. So like I said when we started, the whole independent, dependent, it all comes down to, is it with replacement or without replacement? That's really what you're looking at. That's really what you're asking yourself. So to finish this one off, well, the probability of picking a green marble is 3 out of 50, and then without replacing it, and then the probability of choosing another green marble. Well, if we took a green marble out, we only have 49 total marbles, and if we started with 3 green marbles and we take one away, we only have 2 green marbles left that we could pick. So we have 3 over 50 times 2 over 49. Now I'm going to simplify it before I multiply it out because that's my preferred method. 2 goes into 2 once, 2 goes into 50 25 times. 3 does not go into 25 or 49, so I'm done simplifying and I'm going to multiply. 3 times 1 is 3. 25 times 49 is 1,225. So our probability of picking a green marble, not replacing it, and then choosing another green marble is 3 out of 1,225. And that's our answer. So again, this is just to emphasize the difference between those probabilities. Simple, there's one thing going on. It's favorable over total. That's it. Or probability, it legitimately has the word or in there, and you have to remember to subtract that overlap if there is any. And then independent, dependent, you are multiplying, not adding for these ones, but multiplying. And remember to decide if it's independent or dependent, you just ask, does it have replacement? In which case it's independent because you're resetting everything, or is it without replacement? In which case you are changing the conditions for the second, third, fourth probability you might be finding. All right, if you have any questions,